name is Alicia Grosso, and I will be presenting a portion of my dissertation, Tissue Variability Effects on Saw Mark Evidence in Bone. Forensic analysts must make use of whatever evidence remains, which in cases of postmortem dismemberment may include saw mark evidence in bone, which has the potential to not only show that a crime has occurred, but also helps narrow down the identity of the saw. Forensic anthropologists testify on this evidence in court, and admission of this testimony is guided by the Daubert standards, which requires scientific testimony to be tested, peer-reviewed, and present a known or potential error rate. Methods like saw mark analysis must be subjected to validation studies to show their accuracy and repeatability. My dissertation is a validation study of microscopic saw mark analysis, specifically looking at how variability of bone being cut affects the accuracy and precision of what we call tooth hop, in its reflection of tooth size of the cutting blade. Tooth size is measured by teeth per inch, or TPI. Typically, when material is sawn, striations are in line with the sawing action, but sometimes these striations are wavy and resemble the saw teeth, hence the name tooth hops. For my dissertation, I asked, how variable will saw tooth hop measurements be when comparing multiple usages in human bone, and how does this compare to common animal proxies like pig and deer? Ultimately, I measured 280 tooth hops from human bone, 689 from deer, and 797 from pig. I also collected 50 measurements from adjacent teeth of the blade. The figure at right shows the mean and variance of tooth hop measurements for each of the groups, blade, deer, human, and pig. As you can see, variation expressed by the blade is minimal as compared to variability introduced by the bones. Significant differences are present amongst the groups. However, measurements are in millimeters. Sawtooth size is measured as number of teeth that fit within an inch, hence TPI. Thus, these significant differences in millimeters are masked. Almost all bone-measured tooth hops here suggest a blade that was 6 to 9 TPI. The blade used was marketed as 7 TPI. For these results, I present here two significant implications for the presentation of tooth hop evidence in forensic case reports, including, given the variation that can be exhibited by humans, I suggest the presentation of a mean tooth hop plus or minus 2 TPI, which means in this study a range of 5 to 9 TPI. Finally, because of the necessary conversion to TPI, fresh pig and deer bones can be used as substitutes for human bone when studying tooth hop. However, striations from saw blades are scratch marks a hard saw leaves behind on a softer surface, bone. This means that tissue hardness is the primary feature affecting tooth hop presence and variation, so saw features relying on bone properties besides hardness must be further evaluated to know if these non-human substitutes are acceptable. Thank you.